Good morning, everyone. Hope you guys are having a good time. This session was originally targeted at business group, that group of individuals who wanted to start a new business on the technology domain. So this initial parts of the session focuses mainly on the concept, and then we look at some of the use cases, so that anyone who wants to start a new business. And I changed few slides to make it more suitable for a bunch of undergraduates and people who are interested in technology. Feel free to ask questions at any time. Raise your hand and I'll get the question from you. And also at the end of the session, we'll have some time to discuss things which were not clear or any other questions on that. And I'm happy to be here today, not because it's a working day and I get to stay away from office, but I'm really excited to share knowledge on this domain. Let's get started. Let's see what we have to present today. All right, so this is reality. When you see outside, this is what you see, right? And the good thing is you can walk into, this is School of Computing. You guys all belong to School of Computing. And I can easily put a picture out there and say, this is reality, and everybody goes like, yeah, that's reality. And in any other school of, something like School of Psychology or Philosophy, if I say this is reality, they would disagree with me all day. They would say, no, this is not reality, this is just a snapshot of this, and reality is interpretation, how that works in your mind, and so many theories. But computing students, they're like, yeah, that's reality, that's good. So in order to understand augmented reality, it's really important that we understand reality. So when you look outside, when you look around, we believe what we see is reality, right? So I'm not going to challenge that. I'm going to take that as a reference point and then build my case on top of that. And you see the world in through some kind of device. Could be your glasses, specs, or it could be through your mobile phone. The only difference is when you look at the reality through a mobile phone or through a device, that device can bring information related to the reality, context sensitive information related to that reality, and print it as a layer on top of the reality. So you're living in this space, in this reality, and when you look at that reality through a device, you see extra set of information on top of that. So in a nutshell, this is the augmentation, or this is augmented reality. You are perceiving the reality with extra set of information. That extra set of information can be text, images, videos, any multimedia for that matter. Let's look at another example outside of computer science. This is a cockpit of a fighter pilot. This is how they see outside. So in the air, it's really hard for you to make a reference. Like if you're walking on the road, if you're driving, you can make references to points like landmarks and things like that. But when you're in air, it's the sky all around. It's really hard for you to know where you are. So they've been using augmented technology, something like this. In the helmet, a projected information about their environment is projected, a layer of augmented information, so that it makes sense for them to make decisions while flying the aircraft. So this is one example, which is just to give a point that this is kind of out there. It's not a brand new technology. In fact, when we look at how all this technology, you'll be surprised to see how all this technology is. Okay, let's go back in time. Let's understand a little bit of history, what makes augmented reality and how that got into the industry. So far, are we good? Do you guys understood what I just said? Clear? All right. Anyone heard of this guy? He's a author, amateur guy who's predicts future. In one of his books, that book is called Master Key. He has a story about a character maker. What that character maker does is, this kid wears a pair of spectacles, pair of glasses, and that child can look at people through the glasses, through the spectacles. When you look at a person, and this was written in 1901, right, long time ago. So you look at a person. If that person is good through your glasses, you see a letter G on their forehead, right? Reality is the person. When you look at it through the spectacles, the glasses, augmented layer of information. It says this person is good, bad, ugly, or whatever. What do they say? Good, evil, wise, foolish F, and kind K, and so on and so forth. So this was the concept. This was known as the prediction of future for the augmented reality. So the last statement, single look through the natures of those who encounter. You see a person through the glasses and it says this person is good or bad. So 1901, the concept was written in a children's storybook. Then 1990, Tom Cordell, he works at Boeing at that time, the company that makes aircraft. He was told in the manufacturing plant, you have lots of diagrams about your aircrafts, right? So lots of boards hanging around, like whiteboards in your session. And every time you change, slight change, every time when you make a change to the diagram or a semantic diagram or whatever that is, you need to replace that board, which is tedious, which is difficult, and definitely expensive. So he was asked to come up with a simpler solution. That's where he talked about come up with an alternative to the expensive diagrams. So in 1990, he came up with this technology. Instead of having boards all around the manufacturing plant, people who are working will wear special glasses. In their glasses, they'll have information projected. Heard of Google glasses? This was Google glasses in 1990, right? So, how many years old? 10, 20, 26 years old. It has been there for 26 years. How many of you guys are older than 26? I'm older than 26. Pretty much everyone was born after 1990. So this technology is older than you guys. Right? Okay, now the point is, in 1991 it was predicted. It was written in a storybook. In 1990, it was implemented. And why are we talking about it today? Why are we talking about it in the present day after 26 years? So another example of your physical reality and the augmentation. The deal with augmentation, there has to be a bit of reality in that view, in the background. In the foreground, you can have some digital content. Right? So coming back to that question, why are we even talking about a 26-year-old technology, and why are we so excited about this technology today? Can anyone guess why are we so excited about this technology today? Okay, so let's see whether what you guessed is right. This is just a summary of. So it's a technology that superimposes real world view with computer generated content. That's what we've been talking about. So Pokemon Go game is based on bit of virtual reality and bit of augmented reality. At the last stage, when you want to capture that Pokemon Go animal, it's augmented reality. You are looking at the reality through your phone and you see a Pokemon Go animal. And the other thing is, a lot of people misunderstand augmented reality is something only in mobile devices. It's not the case. If you read the second and third line, your viewing screen such as monitor, mobile phone, helmet face mask, which is the fighter pilot's case, glasses, goggles, head mounted displays, and even your automobiles in your car's windshield, automobile windshield. The deal is all this information has to be projected, augmented in real time. It's not like you're at this location today and tomorrow morning you get some information augmented on the screen, then that is too late. It has to be at this point. Right? Now, for instance, if there was an augmented reality app where I can point at this crowd and figure it out, who has a car at this point, who is interested in augmented reality at this point, that makes sense. That I get that information real time. Okay, so let's look at some of the points just to reiterate the augmented reality concept. If there's no reality, there's no augmented reality. So for you to have augmented reality app, there has to be a way of capturing the reality. So easiest way to capture reality is via a small camera. Layering of computer generated info over a canvas of reality, same thing that we looked at. It's kind of information decoration of the reality. Combine real and virtual info. Now let's slightly get into a tangent and talk about virtual reality versus augmented reality, right? In virtual reality, which is parallel to what you live in augmented reality, you take your reality and then put layer of information on that. But in virtual reality, you may be seated here, but when you wear VR goggles or when you are in a VR system, it gives you an impression that you are in a different location, a parallel universe. Most likely your surrounding is created using graphics, animations, and you get to do things which you might not be able to do it in your real life, right? It's a different experience, it's a parallel experience, whereas augmented reality is an enhancement of your current reality. So that's the main two. In some of the scientists suggest augmented reality, also known as mixed reality. You're here, you see the reality plus augmented information, and that's a mixed mode. So that's called mixed reality as well. And there are other realities called, which is not categorized as VR or categorized as augmented, a combination of both, or if you bring another dimension to that, that's known as other realities. We'll probably not touch upon those today. So that's the major difference between VR and AR. So eventually it makes the reality much richer and interesting with the information that you provide. So my question that I asked before, 26-year-old technology, why it is important today? This is why it is important today. So if you look at, so before I answer that question, this is more of a timeline of how augmented reality got a trend. At the very end, the spike that you see is somewhere in 2016, June, July. That is where the Pokemon Go game got popular. People again started searching what's augmented reality. So it got somewhat popular. From 2011 to 2016, it was trending on average, so there was no spikes. So if you build a product, and if everyone in Sri Lanka started searching about, if you build a product on augmented reality, and if everyone in Sri Lanka started searching about that product and trying to understand augmented reality, you will contribute to make a little spike in this diagram. Okay, so hopefully next slide will answer the question, why augmented reality is important today. Even though it is 26 years old, only very recently it became implementable in a very reliable and very cost-effective fashion, right? So think of it this way, right? In 1990, if they wanted high-definition monitor, how much money and time and effort they need to put into get a high-definition monitor, like a small screen. High-resolution camera, if they wanted high-resolution camera in 1990, how much money and time you need to spend. But today, every smartphone pretty much has a high-definition HD screen, right? Probably not 1080p resolution, but on a closer resolution where you can read teeny-weeny text. That's how you read your text messages in your smartphone, right? Very small fonts, but it still looks good. That's because of the resolution. And the camera that you have is at least 5 megapixel or maybe more. And that whole mobile phone is only cost you like 25,000 maybe. So that's why augmented reality got popular. People nowadays have very powerful devices in their pocket which got high-speed internet connection, high-resolution cameras, high-definition monitors in a small device. So everyone got a device which is powerful enough, which is single core, dual core, quad core, or so many multiple cores in their pocket. They can use this device for applications. That's where the catch is. So high-resolution cameras on smart devices, high-performing CPUs and GPUs. What's a GPU? Graphical processing, where it can process images. So when we look at Pokemon Go animal, that's a 3D animal. So a 3D animal, a 3D object to be rendered on your screen. If you study computer graphic processing, you would understand a 3D object consists of something called multiple polygons, thousands of multiple polygons being rendered at during a very fast time period will give you a 3D animation. So all that is possible because you have powerful GPUs in your mobile phone, in your mobile devices. Big RAM, so that you can get a lot of content and that content can be rendered in the mobile phone. HD displays, and the other thing is high-speed internet. Because for you to augment something which is relevant to this context, you need to bring that from the internet. So you need to bring information from the internet, you need to bring animation, images, all that from the internet. For that you need high-speed internet, because if you bring that few minutes later, which is not relevant to the current reality, it has to be real time. So that's another reason augmented reality is something very popular today. So back in the days, 1990s, think of having a high-speed internet, HD cameras, high-resolution cameras, HD monitors, RAM, CPU, GPU, all that would have been really, really, really costly. So people did not invest and create systems which can go to consumer markets because of that point. All right, so now we're going to talk about a little bit of on the technical side. So we understand the concept. Concept is simpler. Capture the reality, get a canvas of reality, display the reality. On top of that, augment your information. That could be anything from text to videos to 3D models and so on and so forth. So in order to do this, there are three main solutions, three main categories as of now. Category number one is called sensor-based augmented reality. The second category is called vision-based augmented reality. Third one is sensors plus vision, is called hybrid tracking. We'll look into 3 different examples of these. All right, let's look at the sensor-based augmented reality, which is the most popular kind. What it does, your phone has sensors like GPS, the current location, so it can understand what this location is, right? Long and length. A compass, a direction. Then the gyroscope, which can detect the angle. Accelerometer can detect whether you're tilting the phone, whether the phone is looking up or down. That's how it changes you're looking at a picture when the phone is horizontal, and when you flip it up, image changes. The gyroscope in the mobile phone tells the orientation changes. It's a sensor inside the mobile device, just like GPS and compass. So from those sensors, now this is an example of that. From your mobile phone, you're looking at a location. You pick current coordinates. What is this location? The compass, the direction that you're looking at, and the orientation of the phone and the angle. And you send this information to the cloud and say, hey, according to the device, I'm at the UCSC Fine Arts Theatre, and I'm looking at, this is what, east maybe, and so on and so forth. Based on that internet, from a web server, go to a data store and bring some information back. And that information is augmented on this canvas. So that information is relevant because your mobile phone knows which location you are and which direction you are looking at. Moment you change the direction, it will make another call to the cloud. Now give you information in that direction, and it will come down to your phone and augment it. So this sensor-based augmented reality is the most simplest one. Mobile application developers can build this really fast. There are lots of SDKs, developer toolkits, you can download and integrate services with this. Let's look at the other category. Vision-based VR. What this falls under image processing. The first one does not care about the image processing part. It simply cares about what the sensors tell you where you are. This one does not care about what is the location, the GPS location, and so on and so forth. It looks outside and it is looking for a code which it can detect. Highly likely that code is a QR code. So you might have seen in magazines, you get a QR code. You point your camera, scan that QR code. On top of that QR code, there comes a 3D animation. So that's where the vision-based augmented reality works. It looks for an image, a code, encrypt it, get the information and play a video, text or information related to that. So this example, you have a 2D plan, a paper printed plan, a blueprint. When you look at it via a phone or a device, it shows you the 3D picture, a 3D model of that plan. Right? Again, it's very simple implementation. All it does is it looks for a certain QR code or a barcode or any kind of a code that the device can process and augmented a 3D model on top of that. Right? So this has a lot of use cases. Think of it this way, right? If you study some subject where it requires you to look at 3D models in a book, you can't print all that. But in the book, you put a small QR code. You look at the QR code via the mobile phone, and you see a 3D animation then and there. All right, so let's move on to the other category, hybrid tracking. This is not a perfect example though, but what this does is, this has quite a few things. One is, so this is the weatherman, like talking about the weather. What you see in the middle is augmented information. That's, in reality, it's not there, right? So instead of that, what they have is a table with 4 QR codes at the 4 corners of the table. So it demarks this is the boundary of the table. And the camera moves. When the camera moves, it needs to pick the angle. So that's where the sensor part comes in. So it has codes plus the sensors of the camera to get the direction. Based on that direction, the middle image gets rendered, and the end user sees a 3D animation in middle of a video. So this is something, again, simple to implement. Lots of open source as well as free SDKs for you to implement something like this. All right, so that's actually concludes the 3 categories. So we looked at sensor-based AR, and then we looked at vision-based AR, and then we looked at the hybrid version. Some of the use cases. What category of AR is this? Is it the sensor, is it the vision, or is it the hybrid? All right, okay, so it's sensor-based AR. This is your mobile phone. You point it at a direction. Sensors like GPS, compass, they all give you the direction, sense of where you are. Based on that, you pick information. So it tells you there are restaurants all around, and each restaurant's another point of interest, and they are rated and how far they are. What's the difference between this and Google Maps? Do you know, in reality, only a very small percentage of people can actually read a map. Have you really tried looking at a map and figuring out where you are and how to go to another location? I'm not joking. You search on something called multiple intelligence, right? So the general intelligence that we generally talk about is IQ. Everyone, if you have IQ, you are good at it. But the intelligence is way more than that. There are 8 other categories, altogether 9 categories. And one category is about the spatial space for people to understand the direction. So if I asked, which direction is the sea? Point your hand to the direction of sea. I'm sure, even though you guys have very decent IQ, most of you fail to point that, because that's a different intelligence. And if you don't have that, don't think you're dumb. It's not that, right? You have other intelligences, but some people can't read maps. That's what it is. But application like this boils down information to a particular direction so that you're not lost whether this point of interest is here or there or which direction. It directly tells you that. Education. Now this is the example I talked about minutes ago, where in your textbook you can't embed all the graphics, color printouts and all that, right? What you do is, in your textbook you can print a QR code, and from the mobile phone, when you look at it, it gives you an animation. That animation comes from the cloud. The good thing about this QR code, you can keep updating the actual model, the 3D model, because that model stays in the server, in the cloud, right? If you make a mistake, it's not like you have to recall the full book and give a brand new book. You can change that model in the cloud. So this year students, when they look at it, they will probably see the model with the mistake. And if someone fixed that problem in the cloud, next year students, when they look at the new model, that error or the problem in that diagram is gone because it's corrected in the cloud. Military combat training. So if we have to train you how to shoot in real life, you have this reality space, and to make you practice to shoot to a target, we need to keep a real cone or some target there, and then make you shoot from a distance and make you practice, right? And while you're practicing, if someone try to cross, there'll be friendly fire and there'll be other complications. But if you bring the augmented reality, virtual content into this, you wear glasses. In your glass, you see a target, which is not a real target in the field. You try to point and shoot. If you build a mechanism to connect your shooting to that digital target, you can build combat training, and you can even do combat training in your room. You don't even need to go to a join army to do that. So these are practical applications and implemented using augmented reality. What's the classification of this augmented reality? Sensor or vision or hybrid? So try to recreate this. So you wear glasses, you try to look at, you change your location, you change your direction, right? So what's the easiest way to figure out when person is looking at multiple directions, changing location? You need to sense that, right? So the mobile phone in your wallet, mobile phone connected to the system somewhere can detect your current GPS and your direction that you have changed. So this is sensor-based augmented reality. Yes, sensor-based augmented reality. Interactive catalogs. Quite similar to the textbook scenario where you don't print your catalog, or you don't put your catalog in a CD. You give a small leaflet, or actually a QR code for that matter. You point. So this is, this is slightly different. You are trying to buy furniture before going to the furniture shop. You are in your room, in your house, in whatever the place, you just need to match furniture. You point your camera and then you think, what is suitable? A green color sofa or a red color chair or a table or whatever. You bring those into your reality and then you look at it and see, okay, whether this matches this location. This is another example of it. What could be this? Is it vision, sensor or hybrid? Does it really matter the direction that you're looking at? Actually, this is what I call dumb augmented reality. It doesn't really sense what your background is. You get your camera, you bring a 3D model to your camera and you make it large or small, right? Because you just want that 3D model to be in that location. That's all you need. So you don't need a sensor for this, or you don't need a vision, a QR code to be decoded. You just bring a 3D model and zoom it or make it small or large and then see whether it fits. What you see is the background in the camera. You can also make this vision based, where you place a small QR code on the floor where you need the table to be, and then get back from your camera, look at that QR code from a distance. The system will replace the QR code with a table or a sofa or whatever the furniture that you would like to buy. Interactive packaging. So in the middle, instead of a QR code, they have another code. It can be any image, as long as your application can understand this image, process the image and say this image means this, you can bring content into that, right? I think this is highly important. This is a very practical use case where you want to print things like calories about food and so much of other information where you don't have enough space to print all that in the packaging. You have a small code in the package, point and shoot the camera, it reads the point and brings all the most up-to-date information from the cloud to the user's mobile device. Industrial use cases where you go to a machine and you just need to figure out, without even opening the machine, whether the gears in this machine to be replaced, or whether you need to replace a pump or a motor or something, a mechanical or electronic in this device, whether you want to replace. How do you usually do? You have a logbook, of that device. You bring the logbook, refer the device number in the logbook and figure it out whether something to be replaced. Right. Think of a solution where you have a mobile camera, mobile app. You go to the device and that device has, okay, I'm not going to say what that device has. You point at the device and suddenly information about that device comes on your mobile phone. How do you do that? What classification of AR will be used there? Sensor, vision, no hybrid. Alright, it's vision. So either it recognizes the machine itself or the machine can have a small code that it can detect and then augment the information. So this is something you can build for your computer lab. If someone wants to know whether this computer has Java installed or whether this computer has .NET installed, Xcode installed, or whether this computer has the virus guard updated, you don't have to sit down in the computer, go to the terminal, type whatever the commands, pull up your mobile phone, look at the computer, and it says what things that computer has installed. Unless your friend has uninstalled it a few minutes ago, you get the latest information. Even your friend has uninstalled it, it should send a message to the server and say, this computer no longer has JDK installed it. So when you look at it from the central server, it says no Java installed on this computer, right? Something like that. So there are lots of use cases on that. And then the Google glasses, which is again augmented reality. Augmented information based on sensors. It has sensors.